Hello, Ashirwad.
Hi Rohit, hope you're doing well. Good
Yeah,
afternoon.
I'm doing well. How are you doing?
I'm doing good too, thank you.
Awesome. So, yeah, we are really glad to have you, Ashirwad, today for the
Same
conference.
here.
And this is the afternoon session's third talk, which is by you. So, could you please give a quick introduction about your role, like what you're doing and what your session is going to be? Meanwhile, I'll share
Uh,
the screen.
yeah, sure. You can share my screen. I have a introduction there. So I'll
Awesome.
start off. Okay. So the
Sure.
topic for my talk would be Refactor .NET Core Web APIs to serverless APIs using Azure Functions. Okay. So before getting into the talk mode, I'll give a brief introduction about myself. I'm Ashirwad. I work as an associate software developer at ESSPL. I'm a C# Corner MVP. I'm a cloud enthusiast. I work around many cloud solution, whether it is Azure, IBM Cloud, or else AWS. Most of my development work are related to ASP.NET and ASP.NET Core. I'm also an UiPath certified RPA developer. And if you want to contact me, these are the links where you can connect with me. And if you have any queries, if you run out of time, you can definitely check in with me over there. Okay. So moving into the agenda, we'll start by discussing what is API. Then we'll move around how can we make one. And post that, we'll have a look about evolution of application hosting platform. And then what is serverless. Then we'll go around Azure Functions. Then we'll have a problem statement which we'll try to solve. Actually, I have an API which solve this problem. We'll try to refactor it and make it serverless. And post that. That's all. And finally, we'll publish the API that we made using Azure Function in Azure, and I'll make the link available for you people to test around. So what is an API? As the picture depicts over here, an API is just acts as an interface between a client and a server, or else it what we say, it acts as a middleman which takes your request, processes it by giving it to the server to process it, and gets back your response. So it's just a simple interface, right? Okay. So how can we make one? Now we know what is an API. So how can we make one? You can use an web API using .NET's web API framework. If you're in Python, you can use Django or Flash to make one. Suppose you're a JavaScript developer, then you can use Express.js and Node.js to do that. Same with Spring for Java. Okay. So next, the evolution of application hosting platform. This is a brief to tell you about how the whole thing started and how we reached a serverless. So back in the days, we had things like on-prem. I have this analogy using which I explain this whole thing, how we went from on-prem to serverless right now. So back in the days when companies actually had the whole servers, they used to buy servers, they used to have these storage devices, networking setups, everything to be done by their own team. So it was really painful. So it's more over like I got a job in Bangalore. Suppose right now I'm based in Bhubaneswar. So I got a job in Bangalore. The analogy is more like when I go to Bangalore, I buy a house just to stay there and work from there. So that was more like an on-prem thing. You buy everything to host an application. But as things changed and the years moved on, something new came to the market. It was IaaS, infrastructure as a service. So what happened here is that now you don't need to buy in the servers. Now you don't need to buy the storage devices to host your applications. So it's more like instead of buying a house in Bangalore, you can just rent one and just pay for the time you're being there and just use it. Now you're completely safe from all the property taxes that you would have to pay if you were to buy a mansion. The same with the on-prem servers and storage devices which you bought and now they are outdated. You don't even need to be bothered about the cost of that because you're just renting it from someone else's system, right? Your cloud providers are more like the person who rent these resources to you. Next is pass. So pass is more like renting a small flat or an apartment in Bangalore instead of going for a house. So now you're safe from the hassles of actually patching the operating system in pass. You don't even need to be bothered about the storage capacity or else what we say, a lot of the things. So this was a way. And PaaS normally solves almost most of the problems that normally when you try to move from an on-prem to the cloud, or you have a cloud native architecture. If you move on, then PaaS is more sufficient. But there are certain things that PaaS even didn't used to do. It was more like you need to have to write rules for upscaling or downscaling your applications. You need to do that because suppose these days Amazon and Flipkart, they have the Great Indian Festival or Big Billion Day sales, right? At the time they have huge spikes in the traffic that they normally get on their website. So at the time they need to scale up. So you cannot manually just scale it because you cannot pick it right time when the spike would go up, right? So it's more of like you need to have this auto scaling rules you need to write, or else you need to have some what we say, you need to manually upscale it or downscale it whenever the traffic goes up or goes down. So this was a problem which even PaaS had. So to overcome this particular thing, we went into serverless. So serverless is more like renting a room in Oyo. You don't even need to have an agreement that you used to have with your house owner when you rent a flat. You don't even need to pay an upfront cost or anything. So the number of days you stay, you just pay for the money for that, and that is moreover serverless. The amount of resources you consume, or else the time your application actually runs, you only pay for that. You don't even need to pay when your application is not running. When there is a downtime, and suppose your application is not being used at all, then why should you pay money, right? So this is moreover like serverless, and this is how serverless came into the picture. Okay, so what is serverless? So there are multiple components which are normally associated with a serverless architecture. So one of them is stateless. The state of the application never stays inside the server. So once an execution is done, all the data that was associated with that particular execution is lost. You're not going to get that back. It's not going to be persistent. It is event driven. This is another thing that is always associated with the serverless architecture. So event driven is moreover like there is an event which triggers your application to run, and this is how the whole application works. Suppose somebody knocks your door, you open it. Unless somebody knocks it, you're not going to open the door, right? So it's moreover like that. Next is micro billing. You only pay for the time your application is actually running. So if your application is running for a second, you only pay for the second, not more than that. So abstraction of servers. This is what serverless actually is. It's an abstraction of infrastructure management. So this is the essence of an serverless architecture. Okay, so what is Azure Function? Azure Function associates all those things that are associated with a normal serverless architecture or an application made using serverless architecture. So this is a serverless offering offered by Azure. So apart from the four things which we discussed in the previous slide, one more thing comes into the picture in this slide is function as a service. Azure Function is a function as a service of offering of Azure. So in this, you can write function as a service, which is normally a chunk of code which you can execute whenever a particular event happens. And after the event, is done, is successfully executed, your function goes back to sleep or it's in an idle state. Okay, so that was more about Azure Functions. So since the topic was more about refactoring and .NET Core API to a serverless API using Azure Function, we will not get deeper into what Azure Function is and what triggers and bindings are here. So let's get into how can we make one. How can we make an Azure Function? So there are multiple ways of making one. You can make one using Azure Portal itself. You can make one using Azure CLI. You can make one using Visual Studio, Visual Studio Code. Okay, so apart from that, even if you use any other IDE like Atom, Sublime, you can also make that, provided you have the function runtime tool. So you need to install that, and after that, you're good to go. You can absolutely write one using any other tool. Okay, so let's make one using Azure Portal. So let's go to okay, let's go to okay, this is my Azure Portal. I have logged in. So let's create a function app. So inside of function app, all our Azure functions are there. This will be a quick demo on how to create an Azure function using Azure Portal. So post that, we'll have a look at the problem statement. Since I thought many of you may not be knowing, that's why I'm giving demo on that, and it's good to know. So as the resource could let the resource will be the same. Test stays demo. Select it as okay. So here you can see that Azure Function supports a lot of languages. You can write one in Node, .NET Core, Node.js, Python, Java, PowerShell. You can also write one in TypeScript. So I'm selecting the runtime stack here as .NET Core. The version is good. Let's select as US East US. Okay, it's the hosting. So while going through, we can discuss normally the things that are associated with Azure Function. So you need a storage account because though your Azure Function is a serverless offering, but still it needs to store its data somewhere to process it or to execute it. So we'll have a storage account associated with an Azure Function, but it completely depends upon you. If you have an existing storage account, you can also use it with your function app to run your Azure functions. I need not bother about this. Okay, let's click on review and create. Let's wait a while. Okay, it's done. Let's create. So this is how easy it is to create a function app in Azure portal. So once it is created, we'll go inside portal and create an Azure function and test it. Okay, it should take some seconds to complete. Should take a longer time. Okay, should be done in a minute. Okay, so since it is taking some time, I'll say about a few terms which you need to be familiar about while working with Azure Function. So one is the trigger and the other is a binding. So trigger is something which invokes your Azure Function to run. Triggers can be anything in Azure Function. There are multiple triggers and bindings available. So some of the triggers are HTTP trigger, there can be a blob trigger or a Cosmos DB trigger. And if you want to know the supported bindings and the triggers which are supported, then you can have a look over here. This is the link. You can use this link to check it out. And okay, there are some what we say, some offerings which works with the function runtime 1 and doesn't work with 2 or 3. So here you can find all the details, and you can just have a look over here in the documentation part of Azure Functions. Okay, so it should be deployed by now. Okay, so now it is deployed. Let's go to the resource. Okay, to create a function, you need to go over here, click on the function. Now you need to add one. Just a minute. Okay, click on add. Now we are creating an Azure function. Function app is nothing but a logical grouping of your Azure function. Now, if you need to select the development environment here, if you if you select the development environment as VS Code or any other editor, then you cannot make any changes over here. You cannot write anything over in the portal. So I have selected the template as HTTP trigger. So whenever our function gets an HTTP request, then it's gonna be invoked and it's gonna run. So Azure function is ready. So our template is ready and good to go. Let's click over code and test to see it. It's taking some time. Let's wait. Okay, it's loading. Let's wait a bit. Okay. Okay, so this is the template that we got. Let me describe you a bit about this function. So it's taking an HTTP request object that is direct, and we are trying to gather we are trying to see whether any value was passed in the query string or else in the request body. If it was, then it is trying to find it out and store it in the variable name. If something was passed in request body, it is trying to deserialize it and then store the value over there. And once you get the name, then it is just checking whether it is null or empty. If it is null or empty, then it's going to say the HTTP function triggered functions executed successfully, but a name was not passed. If it passed, it's going to say hello message. You can test it out. Just take the URL. You can directly do it over here. Name Ashirwad. Yeah. Okay, just a minute. Okay, let's test and run it. Okay, it fired over here, as you can see. You can test it out here as well as over there, but due to some reason it wasn't working. So let's check it out. Okay, that's all about the demo in Azure portal. Let's go back to the slides. Okay, so let's go to the problem statement. So the problem statement is more like you're working at an organization, India Inc. Incorporated, and of late your organization has been able to retain many of its existing customers. You know, was not able, not able to retain many of his existing customers. To understand this, you're sharing a feedback form with your customers to share their experience with your organization. Now the management wants to receive all the negative feedback shared by the customer to address this concern and work on them. It's more of like you're losing your clients, but you don't know why, so you're sending forms so that you can know what is the reason because of which they are leaving us. Maybe they are not satisfied with the product, so you're asking them to give their feedback about a particular product, and if they're giving negative feedback about the product, you need to inform the management about it. So I have designed an API which does that. So it takes the feedback from the customers. It does sentiment analysis on that using Azure Text Analytics. It's trying to find out the sentiment score about that. If it is positive, then it sends what we say. It sends a mail to the customer that we are glad to have you or something like that. But if they're unhappy, then you say that we regret for the experience you had, and we'll try to improve more, as well as share the feedback that the customer shared with us through the form to the management. You need to mail that particular feedback to the management. So this is the thing that we want to do. So how do we do that? Let's have a look at the API. Okay, so this is basically the API. There are just two methods over here: get feedback, submit feedback. So let's start with submit. I'll be using Postman to send the request. So I have Postman over here. I'm going to submit one. So let's start our API. We have some breakpoint because we wanted to know how the flow actually happens. Then we'll see how can we refactor the same. Then how can we refactor the same API to a serverless API using Azure Functions? Since at this start, I'm gonna go to Postman. Just gonna do some modifications over there. Okay, since I have already given this data, I don't want to put it out. Let's use Rohit's name. But the mail ID be the same. Product ID. Okay, let's keep it as it says stays. Product. Let's say that the conference is a product for the time being, and the product ID be 3 or something like that. And let's check. Okay, it's running. So let's send the request. Okay. Just inform. Just a moment. Let me try it back. Sometimes things happen in the demonstration when you make it. You often don't. Okay, Git feedback seems to be working. So let's try again. What's happening? Okay. Okay, so it did hit a breakpoint, and finally it's working. Thank God. So let's get into the business of the application. You can see we're trying to find out the feedback rating of the feedback that the customer had given on the particular product. So let's get deeper into it. Let's see what it does. It's a very simple thing. I'm just consuming the text analytics SDK of Azure to do the sentiment analysis over there. So I'm passing in the feedback. I'm trying to get the whether the feedback was positive or negative. So okay, let's see what it was. The sentiment was okay. Okay, we'll see it in the next slide. Okay, so okay, let's see the feedback rating. It was positive. That's good. Now we need to send a mail, right? So let's look at the email helper class, what we have written here. If the feedback is negative, then you need to send a mail to the client as well as one to the management. So since this time it was positive, we are only going to send the client that thank you for your feedback. So I hope it's done. Now you're going to insert this record to a DB. This is an Azure SQL database, and if you go into it, it's a very simple Dotnet code that I've written over here. You can use entity framework. I just wrote it to make the demonstration pretty simple, to be honest. Not everyone is aware of ORMs. So one record was inserted. We can just hover over here and see one was inserted. Now we are going to return the feedback. And let's click on continue and see what we get. Okay, got the same thing. We can now go over here and check it out. Previously there were 3 records, now there should be 3. 2 records, now there should be 3. Okay, great. So this was the simple thing. This is a very simple API that we made over here. Okay, so these are these are what we say. I have a business layer, there's a DAL, there's a model, there's a utility class, and there's the API. So while converting this particular API to a serverless API, do I need to create all of these things again, write the business again, write the DAL again, write the model again, or the utility again? No, the answer is simply no. It's pretty simple. So how do we do that? So to do that, what we need to do is this. Let's open Visual Studio. I'm going to run it as an administrator. Click on run. We'll be adding the DLLs of this particular APIs, the business layer or the DAL, as well as the utility and the model to use, so that we can do code reusability. So let's wait a bit. It's taking a bit longer. So once the templates are loaded, we'll go with the Azure Function template. You can also find it over here. When you go to cloud, then you can see Azure Function, but you need to have the workload of what we say Azure SDK installed in the you can do it in the Visual Studio installer. While doing that, you need to install that particular workload, and it's good to go. Let's name it as OSS days serverless API demo. Let's create one. Okay, you can see there are so many triggers available, which can invoke our particular Azure function. But we are interested with an HTTP trigger because we are trying to make a simple API. So let's keep it anonymous. Authorization level as anonymous, because we don't need to, we don't want to actually pass in a master key or else a key for a function to, check if the user is actually authorized to use it or not. But later, if you're working in a production environment, then these things comes into picture. But since it's a simple demo, I'm just gonna go with the anonymous part. Okay. Okay, let's wait a bit. Let's call and install some of the dependencies. We can see some swigglies or not. It's restoring the packages. Don't worry about this red swigglies. It's gonna go in a while once all the packages are installed. Okay, that's great. So for each API, for each action method we had inside our control API controller, as you can see over here, we had one action method for get feedback and another for submit feedback. So each of them are gonna be separate functions. So let's change the function. If you want to change the function name, you can rename it over here, but renaming it over here doesn't make any changes, to be honest. Let's keep it as get feedbacks. Okay. But still the function name wouldn't change. You need to modify it over here in this particular attribute. Now since it is a get request, we are just gonna get it. We don't need we shouldn't allow a post request to be made over here. If somebody makes it, then you're gonna say it as a bad request. Okay, the authorization level is anonymous. You can use this particular attribute to customize the route of your function. For the time being, we're not much concerned about that. Okay, we don't need any of these things for the time being. For this particular API, we don't need any of these things. So let's clear all this. Skip it as empty. Now, how can we reuse the the business layer or whatever we had written over there? Let's go over browse. We are gonna add all those DLLs. Go to desktop in the new folder. I have my APIs. Okay, so let's go to business, then the bin debug .NET standard. Okay, I'm gonna select all of these DLLs. I'm gonna add them this particular application. But these DLLs or these projects have some dependencies. These dependencies can be like I need to install data.sql client for the DAL. Similarly, for utility, I was using SendGrid to send a mail, and using Azure Text and Analytics to to do the sentiment analysis. So I need to install those even over here. So you can do that by using the Nugget package manager and just install them. So I have used Newtonsoft. So okay. So since I had used Newtonsoft, I need to install it over here. Next, uh, data.sql client. Okay, the system.data.sql client. I need to install that for my DAL to function properly. Okay, so these things are installed. So we are good to go for to write our first serverless API or refactor our first serverless API. So right now what we need to do is that feedback business. Okay, what was the name over here? Feedback business, right? We need to create an instance of feedback business class over here. Sorry. Okay, so now you need to call the particular library using OSS days dot business. You can see that our project name, the business layer's name was OSS days dot business. So I have used that. Right now what I need to do is data. I'm gonna store the feedbacks that I get. Then I'll call this particular method get feedbacks. Okay, once you get that, since it's gonna give me an JSON string, I'm gonna pass in the value over here and let's run it. So this is how simple it is to refactor an existing API to a serverless API. Though I am creating an instance over here, dependency injection is supported in Azure Function, but since it was a bit out of scope of this particular demo and it would have taken a longer learning curve, that's why I haven't included over here. I try to keep it simple, but you can absolutely do it. It is supported from Azure Function Runtime 2.0 and 3.0. It is not supported in 1.0 if you're using that. So let's run it and start our Azure Function code runtime tool. Meanwhile, when I start, I'm gonna just check whether I got the mail or not, right? As you can see, I got the mail. Thank you for the feedback, which I had previously done in Postman, right? I sent a request that this was a really good product, and according to our business, it sent me a mail that, thank you for feedback, since it was positive. Okay, now the function runtime tool has started. So let's wait a while it gives us the endpoint. So the endpoint is, okay, HTTP localhost server. So, okay. HTTP localhost server API / get feedbacks and see whether we get 3 records or not. You get it. So the first part is done. One API is done. So you just need to add the DLLs, and that's all you had to do to get to convert your API, a normal .NET Core API, to a serverless API. So let's stop our function runtime tool. As we are short of time, I have already made a demo for that. So I'm gonna show you this particular thing, like how we converted the whole .NET Core API. Like we had 2 action methods inside our API controller. One was for get feedback and the other was to submit feedback. So I've written both of them over here. I have added the Nugget packages, the Azure AI Text Analytics, Microsoft, the .NET SDK function is something that is required while making an .NET function, Azure .NET function. Then Newtonsoft JSON, which I used to deserialize, and SendGrid to send a mail, and the system.data.sql client to interact with our Azure SQL. So it's really easy even to debug our Azure functions locally before deploying them. So let's run this one and try the submit feedback again. And let's debug it. I have kept a breakpoint over here. So let's wait a while it starts. And once it is done, we'll start the deployment process. We'll publish it in our Azure account. So once we get the endpoint, we're gonna go back to Postman, our pretty own helping tool. So we'll use that and test, and how easy it is to debug your Azure functions. Okay, I'll just go back to the browser, grab the URL. Paste it over here. Instead of get feedbacks, we're gonna do submit feedback. Pathetic. Okay, this was a really bad product. Let's say Copcat, something like that. Okay, let's submit it. Let's send it. Let's change the product ID to, else we can have a conflict. Okay, our debugger did hit our breakpoint. Let's click on F10 and see what the request body got. So over here, okay, so it got here. So now we're gonna deserialize the object. We created an instance of our business layer. Now you can see the data. It got deserialized. It got all the value. The feedback rating it didn't had because we are gonna get it from the inside our business. So let's click F11 to go inside of it. You can see the same process which I had showed you back. Here we are trying to find out the sentiment score or else the sentiment of our particular feedback, whether it is positive or negative. So you see it's negative. Then the rest of the things you saw how it goes. So yeah, now we are sending a mail. Once the mail is sent, Got the feedback. It's done. See the response. You're just gonna get the response of the data that you had shared with the feedback rating. The rating was negative, and let's click on continue and see the response. We saw the response that we got. The feedback rating was negative. Let's go to my inbox and check whether I got another mail or not. I got a few more mails. See, since I was the admin over here, since I am the management over here, my ID was a management that I had explicitly mentioned in the what do we say inside the business. That's why I'm getting the feedback that this was a really bad product. And since I'm also the consumer over here, I also got the message that we regret for inconvenience. We'll try to improvise to make better experience for you. So that's all for the session. Let's publish this one and get it up and running. So to publish it, it's rather simple. It's not quite a rocket science, to be honest. Just click on publish. So once you click on publish, then click on start. Click on Azure. Azure Function App Windows. Function App is nothing but a logical grouping of your Azure functions. So, okay. I'm going to create new function, new Azure Function App to store our Azure function for this demo. Okay, let the name be same, no issues with this. So is serverless APIs. Okay, this is my subscription. Okay, you can choose any of this plan. With consumption plan, there are normally some constraints, like you're going to face a cool start, so it's very minimal, but the first request that goes to your Azure function can have a cool start of a few seconds. But once it is running, then the cool start is nearly negligible. If you want your Azure functions to go up and running all the time, then you can use app service plan or else premium plan. So let's click on create.
I'm sorry to interrupt you, Ashirwad, but
uh,
we are just
yes, Rohit.
out of time.
uh, we are out of, just give me 2 minutes.
Okay, sure.
Yeah, 2 minutes would be enough. Okay, let's create. Now we are creating some resources. So once all the resources are done, we're just gonna publish them, and it's just a few minutes work, and we'll be up and running. Okay, since we are creating resources right now, from inside our application, that's why it's taking a bit longer. But normally, if you have already, a function app and everything already created or provisioned inside your Azure portal, you're not going to face a longer time. Let's wait a few more seconds. Okay. Okay, it's done. It's done. Let's click on finish. Okay. Should. Okay. Let's click on publish. It should go. Meanwhile, the publish process is going on. I'm gonna show you where suppose you're not into .NET, you're using JavaScript, then you should definitely try this particular uh, module, and which is available on Microsoft Learn for free. You can use it to see how you can convert a Node.js or Express API to a serverless API with Azure Function. This is something which prompted me with this particular talk. If you wanted to see all this code and try by your own, you can find it out in this particular repo. This is a public repo in my this is a public repository in my GitHub profile. You can check it over there. uh, let's see if it is okay. Okay, it's deploying. It did start deploying. Once it is done, I'm gonna share the link. Okay. So once it is published, we'll just check the get feedback API that we had created over here, and that's all we are going to do for the time being. In case you have any other questions, you can contact me over LinkedIn, GitHub, or not on Git. Okay, you can post your questions in that particular for that particular repository in GitHub, or else you can connect with me over Twitter. No issues with that. I will definitely answer it over there. S- Okay. I'm really sorry, Rohit. It was taking a bit long time. So okay, so it is deployed. Let's go to our portal and check whether it's there or not. Just demo. Okay. Somewhere. Okay. Oh, is okay. Here we have our API. You can see there are two functions. It should be there. Okay. App is currently in read only. Okay, this should be the one. Okay, it normally takes some time to reflect. That's all from me, Rohit. Are there any more questions?
I'm just going through the comment box. So right now.